multiply fractions. When we're multiplying fractions, we just multiply across our numerators and denominators. But even before we do that, we can look if there is a number in the numerator and a number in the denominator that have common factors, we can divide out those common factors before we start. So for example, if I have a 3 in my numerator and a 9 in a denominator somewhere, I can divide both of those by 3 to make them smaller numbers. So there's a common factor of 3, we'll divide that out. The 5 and the 10 also have a common factor of 5, so I divide those out. And I'm going to get 1/6. So I can multiply across my numerators and multiply across my denominators. Now this strategy is going to be key to what we're doing today, because we're going to be dealing with rational expressions, which I kind of think about as they're like fractions on steroids. They got a lot of stuff going on. So if we can make them simplified, if we can simplify them a little bit, it's going to make the problem a lot easier for us to work on. So that's what we are using as a strategy to multiply our fractions, is just multiplying across our numerators and denominators. And if we have common factors, we will factor those out. So looking at this first problem, we're going to multiply this out and then evaluate for if A is 3 and then B is 4. So we're going to start by looking at the numbers. So I'm just going to circle them quick. So we have all these numbers here. We can look in numerators and denominators and see if those numbers have any common factors. Then we also have some variables, and we're going to look to see if there's any variables that will cancel each other out to make that simplified as well. Now, it could be tempting just to take 3 and 4 and just start plugging those into all these numbers everywhere, but you're going to get some pretty big numbers and pretty tough to work with. So we're going to simplify everything first. All right. So looking at our numbers, we got a 6 and a 4. So since both of those are even, they're both divisible by 2. So that becomes a 3. That's going to become a 2. We also have a 21 and a 7. Since 21 is divisible by 7, it becomes 3. 7 is divisible by 7, it becomes 1. So far our numbers, we can simplify into those pieces. So I'm looking for common factors in my numerator and denominator that I can start to divide out. Next, we start looking at the variables. Any variables that are in common in a numerator and denominator are going to cancel each other out. So first in the numerator, we have a to the third, and then we also have an a. So if you have an a to the third, that's 3 a's, and then you have an a, that's another a, so that's 4 total a's. And then in the denominator, I have a to the fifth, which is 5 total a's. Now the 4 a's in the numerator will cancel out 4 in the denominator. Now if you had 5 down there and 4 get canceled out, you can think about how many do you have left down in the denominator? You're going to have 1 left. So you're going to have an a to the first left down in your denominator. So I have a to the third and an a up in my numerator. Those make 4 a's up there. And then I have 5 in my denominator. So all of them would cancel out except for 1 down in my denominator. And then lastly, in green here, we'll cancel out our b's. So our b's, I've got a 3, b to the third, and a b to the fourth. That's 7 b's. And then I have 5 b's down in the denominator. So if I have 7 up in the numerator, 5 in the denominator, the 5 in the denominator will cancel out 5. I'm left with 2 up in the numerator. So I'd have a b to the second up in my numerator. So remember, I had 7 up in the numerator, 5 in the denominator. We'll cancel out 5 of those. You still have 2 left up in your numerator. Now we're ready to rewrite our fraction. We're going to have a 9b squared over 2a. So there's going to be my simplified version. Lastly, we'll put our numbers in. So the 4 is going to go in for the b right there, and then the 3 is going to go in for the a right there. So we'll put those in and solve that out. And when we do that, we'll get in our numerator, we'll get 9 times 4. Oops, I'm sorry. This should have been a b squared. Sorry about that. Missing on my writing there. So 9b squared, sorry, because I said we had 7 up there, only 5 down in the denominator. So we'll put the 4 into there. That's going to make 144 over 2 times 3, which is 6. 144 divided by 6 is going to end up giving us 24. 4. So there's going to be our most simplified answer once we get those numbers put in for those variables. So you can see again that to multiply these fractions, since they are so loaded up with everything, we want to get things simplified down first. Once we do that, it makes the problem a lot simpler. So 24 would be our answer for our first problem. Now we're going to head down to B. So B, we are going to multiply, and then it says to identify the excluded values. We're going to hold off on that so far. Today we're just going to work on multiplying. So I'm going to multiply my two fractions. You can see I've got a polynomial here, I've got a polynomial here, here, and here. So I've got a lot of things going on. Now, if I just started to multiply these fractions, I would have to do quite a few distributive properties. I distribute everything out, which is going to get totally messy and very long and not very fun to do. But what I can do is I can use that strategy we talked about right at the beginning in our warm-up, is if I can find some common factors, I can divide out those factors to make my problem a little simpler. Just like up above, we had numbers that had common factors. We can do that with these polynomials. We just have to factor out the polynomials. So first I've got this 15 minus 5x squared. So I'm going to factor that first. So I start looking at, I've got two terms, and it's not a difference of squares. So I'm going to start to factor out a GCF. So I look at the numbers, 15 and 5. They both have a common factor of 5. Then I look at my variables. I've got an x and an x squared. Now, since my x squared is the highest degree, I want to make this my leading term. So this is a minus 5x squared right now. So what I'm going to do is I'm going to divide out a negative 5 to change that to positive. And then they both have a common x. So I'm going to pull out my GCF of negative 5x. Then I divide negative 5x squared by negative 5x. That's going to be x. And then 15 divided by negative 5 is going to be negative 3. And the x's are going to cancel out. So we just use the GCF that we did from yesterday, and you also practice that in your delta math, hopefully, to start to factor that first polynomial. Secondly, I've got an x squared minus 4. So I look at, it's got two terms, it's a subtraction. I look at the 4. Does 4 have can you square root 4? Is that a perfect square? Yes, it is. It becomes 2. So this is going to end up being a difference of squares. X plus 2, x minus 2. So we've got that difference of squares happening, x squared minus 4. Next, I've got a trinomial. Trinomials are always going to factor into two binomials. So here I've got to multiply to 6, and I've got to add to negative 5. Well, that's going to have to be minus 2 and minus 3, because negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. And then lastly, I've got to multiply to 9 and add to negative 6. Well, that's going to be x minus 3, because those two numbers will add to negative 6, negative 3 and negative 3, and then multiply to 9. Now, once I get to this point, now I've got all my polynomials factored. I'm going to start looking in my numerator and denominator to see if I can cancel anything out. So right here, I've got an x minus 3. I look in my denominator. Do I have an x minus 3 down there? Yes, I do. So I can cancel out that x minus 3. Next, I got an x minus 2 in the numerator. Do I have an x minus 2 in the denominator? Yes, I do. I'll cancel those out. X minus 3, x minus 3, those would cancel out. When it's all said and done, I'm going to put my answer over here. I've only got a negative 5x up in my numerator. Down in my denominator, I've got an x plus 2. So once I get everything factored, we can start seeing those common factors, and we can start to cancel out any common factors that we have. So we are working on that skill today. We will also see the factoring popping up. Like I said, please continue to practice your factoring. If you haven't done the factoring assignment from yesterday, you're going to want to go back and do that. Even if you get one wrong, you get to see the answer and go back, try again on those problems. But we are going to leave it right there for our notes today. So that is notes 31, day 1, looking at how we can multiply rational expressions. I'm going to stick around if you want to stick around to go over some delta math problems. I'll be around till 8:10, but you can break off to work on your own. Tomorrow we'll finish the notes looking at dividing rational expressions, which we'll still be using the same skills that we've talked about today. So if you're ready to break off on your own, you can break off on your own. I will be around to help out if you want to go over any problems from your Delta Math today. So have a great day, and we will possibly see you sticking around or see you tomorrow. You too. See ya.
Junior, and now Tyler Conklin.